Hello, I, Dr. Minal Nerkar, welcome you all to this session on binary search algorithm using the iterative method. In this video, we are going to learn how to implement the binary search algorithm using the iterative method. In our previous lecture, we studied linear search and sentinel search, where the elements are checked sequentially one after another. Today, we will learn a much faster searching technique that is called as binary search. Binary search is one of the efficient searching algorithm and it follows the divide and conquer approach. So divide and conquer is one of the algorithmic design strategy where, as per the name, the if the problem P is given, and that problem is large, then what we are doing is we are dividing that problem into small sub problems, and this division we are continuing until we got the size of the problem small enough to get the solution. Once we are able to get the solution of the small problem, then later on what we are doing is we are combining the sub solution of all the sub problems together to get the solution of the bigger problem. So this is how divide and conquer strategy works. So binary search makes follows the divide and conquer approach while implementing it. Now, then, binary search, it can be applied only to the sorted array. This means that all the elements must be arranged either in the ascending order or the descending order. Binary search is an efficient searching algorithm that works by repeatedly dividing the search space into two parts. Instead of checking every element one by one, binary search compares the search key with the middle element of the array. Based on this comparison, it eliminates half of the elements from further consideration and focus the search on rest of the half part. Okay. So we will continue this process until the element is found or the search space becomes empty. So this is why binary search is much faster than the linear search for large sorted database. Now here is the example how the binary search works. Now if you see here, this is the input array of size 15. So in total it contains 15 number of elements. Now suppose we want to search the element 105. So how it works, it will start with the lower bound as 0 and upper bound as 14. So this entire array is acting as a search space for the first call. Then we are finding out the mid of this array. So mid is coming out to be 7. Okay. Now we will compare this mid element with the element to be searched, that is 105. As 105 is greater, we are focusing our search on this part of the array and we are totally neglecting this left side of the array. Now we will repeat the same process. Now for this, as we have already compared the element 7, so now the lower bound of the new array will be 8 and the upper bound of the array will be as that of the previous, that is 14. Now for this array we are finding out the mid element. So the mid index is coming out to be 11 and The element stored at the mid is 115. So 115 is getting compared with element to be searched, that is 105. As 105 is less than that of the mid element, we will neglect this half part and we will focus our search on this part only. Okay. Now again, there is the updation in the upper part of the array. So upper will become 10 and the lower, there will not be any updation in the lower index of the array, that will remain 8. So now for the this sub array, the mid is coming out to be the 9. Okay. So now 95 is getting compared with 105, and as 105 is greater than that of the 95, we will focus our search to the to the right side. So now for the right side array, the range will be, lower range will be 10, upper range will be 10, and obviously as there is only one element, so that 105 is getting compared with 105, match is found. So we found the element to be searched, that is 105, at the index 10, and the algorithm terminates. So this is how it works. So when once the search reach to this level where every individual array size is 1. So if you observed over here, lower range and upper range is same, this implies there is only one element in the given array, and as there is only one element, so either if the match is found, the element is present, and if that match is not found at this level, this means the element is not present. This is how binary search works. Now moving to the next. So over here you will get a clear picture. Initially range is this to this. Now the range is changed. It is from this to 9, and then again the range is changed. So this is for, from the animation it is clear to all of you that how the binary search works. Now this slide shows us the comparison between the binary search and the linear search. In case of binary search, we will get the element to be searched in very fewer step. Over here I want to search the element 37. Okay, so only within the 3 steps we can able to get the element, whereas in case of sequential search it requires 11 number of steps to find the element 37. So from the diagram it is very clear that the number of steps required in binary search is less as compared to the sequential search. Now moving to the implementation part, the iterative implementation uses a while loop to iteratively divide the search space into two parts. This means the given implementation makes use of divide and conquer approach. So let us first understand the algorithm step by step. First we define the function binary search. Its return type is integer and it is taking in total 4 parameters. Here array is the sorted one, which is the necessary condition for the binary search to work. Then x is the element to be searched. Then low is the lower bound of the index and high is the upper bound of the index. The while loop executes as long as the low is less than or equal to that of the high. Inside the loop, we calculate the mid of the given array. Okay. Then next we compare the search element with the array of mid. Then there are three possibilities. After comparison, there are three possibilities. Either the elements are equal, or it is less, or it is greater. So the first condition or the first case over here is, we will check if the elements are equal or not. So x is equal to array of mid or not. If equality is there, we will simply return the mid, that is the index of the match found. Then if x is greater than that of the array of mid, we search in the right half by updating the low pointer to mid plus 1. Otherwise, we search the left half by updating the high to mid minus 1. And this process continues until the element is found or the search range becomes empty. If the element is not found, then the function returns minus 1. This is how the binary search works. Now, coming to the analysis part. In the analysis part, as we have seen over here, initially the total number of elements to be total number of elements from which we have to search the element, if it is equal to 15, so in the mid of that is nothing but 8. Now for the next iteration, the size of the search space is reduced to exactly half. Now for the next iteration, it is again reduced to the half of the previous one. For the next iteration, it will become n by 8. Likewise, after certain number of iteration, the size of the array will become 1. Okay. So now how we can represent it? The size of the array will become 1 in or at the ith iteration. So that is n divided by 2 raised to I is equal to 1. This is nothing but what? N is equal to 2 raised to I. Now taking the log of both the sides, we are getting the expression log of n is equal to log of 2 raised to I. Now after this, what we are doing is log to log of n, which is equal to I into log of 2 to the base 2, because we are taking the log to the base 2 of both the sides. Log to the base 2 of n is equal to log to the base 2 of 2 into this I. So now log to the base 2 of 2 is nothing but 1. So now the solution that we are getting is log to the base 2 of n is equal to I. So I is representing over here is the level at which we come to know that if the element is present or not. So the time complexity of the binary search is coming out to be the log to the base 2. Now coming to the worst case, best case and average case analysis of the binary search. In the best case, the element is found at the middle position in the first